Alright, here we are to talk about density porosity. So our density porosity tool, the purpose of running that is to have a measurement or an estimate of porosity in our formation. But in this case, this tool uses a gamma ray source, and our measurements will be related to the formation's ability to absorb gamma rays and also with the electron density of that formation. So we will see the details in a few minutes. One more time, why running a density porosity tool is to have an idea or a value of porosity that we will use to solve our cheese equation and get water saturation, and after that getting hydrocarbon saturations. So these are another applications like determining the volume of shale, identifying gas bearing formation, hydrocarbon density, and hence evaluation of shaly sandstone, determination of overburden pressure, and the mechanical properties of the rock. Where can I run a density tool? Anywhere except on case hole. Now, the physics of the measurement. Here are two keywords, scattering and absorption. For the moment, let's just make a connection between scattering and electron density. I mean, the quantity of electrons in a volume. And absorption of gamma rays will be related to the atomic number of the rock. As I told you, this tool uses a gamma ray source, could be a cesium-137. It will depend on the service provider, but this one is very widely used. The important thing is that to generate gamma rays, which will be high energy level. And to understand how we go from gamma rays to porosity units, first let's see this example of an atom. There are electrons on an inner shell and there are electrons on an outer shell. So our first interactions will be related to scattering. In this picture, our gamma ray is the yellow line. It goes out from the source, then it will collide with electrons on the outer shell, and after this collision, the gamma ray will lose its energy and will continue to exist. Another type of reaction is those related to absorption. In this case, our gamma ray will interact with electrons on the inner shell, and in most cases they will cease to exist. But not 100% of these gamma rays will be absorbed. Some of them will also continue to exist and to be detected. The magic occurs because the density tool is able to read gamma rays from these two types of interaction. The detectors will read the energy levels of those gamma rays, will be able to differentiate which is coming from which type of interaction based on the energy levels. And on the first scenario, on scattering, those gamma rays will help us to determine the bulk density of our porosity estimates. On the second type of interaction, those related to absorption, that those gamma rays will help us to determine the type of lithology. Will give us a value, a photoelectric value, that is an indication of lithology. So here one more time we have a scatter gamma ray. I highlighted this, that electron density can be related to the formation bulk density, expressed in grams per cubic centimeter. And the photoelectric absorption is this one that give us the PE. The PE is related to the average atomic number of that rock. The PE, there are values associated with each type of lithology. Now, the detector, the scintillation detector. Once a gamma ray enters, this is a diagram of the detector. Once a gamma ray enters into this crystal, remember the gamma ray technically is like a small piece of light, like a photon with no mass. So once a gamma ray enters into the scintillation crystal, it passes through this area called the photomultiplier, and the output will be a voltage, and depending of the energy level of that gamma ray that energy level will be associated with the voltage. And this is what makes the separation between different energy levels. This is what converts a gamma ray to a voltage that will help us determine lithology and porosity. This is one more time the formula. Corrections. Corrections are important. Whenever you're presented a density porosity log, you should ask for the corrections, because these things will affect your measurements, like washouts, like mud cake, arugos, hole. Remember, your tool should be in direct contact with the formation. In this diagram, you can see that the density tool, it has a pad. This is the pad, and on the back, it has usually a caliper. This is a model of one surface company. This is a caliper, and this is the pad where the radioactive source is installed. And these are the correction. So washouts result in a positive correction. If you don't have a good measurement from the caliper, probably your measurements or estimates of density will not be very good. So if the mud cake is normal, there will be no big correction. And heavy mud results in negative corrections. This is a picture of a density porosity log, and here is your correction presented. Usually they present both negative and positive corrections. And this is explaining which cases were correction plus, correction minus, etc. Well, that was a review of our density porosity tool. Thank you very much. Thanks for watching.